Following is a video demonstration of the projectile motion function created as part of Engineering 267 at OIT. The function was created on MATLAB, and we'll go ahead and show you the help page here for the function. You can see it provides a description of the function itself, so we can see the input argument here, as well as x0, y0, which are the initial starting position. v0 is its initial launch velocity. a0 is the angle of launch. And finally, dp is the amount of data points along the trajectory path. And as our output, we are looking for a plot of the trajectory, as well as the horizontal range, height of the projectile, and the location of the projectile when it reaches its maximum height. So let's see here, we'll go ahead and bring up this function. And you can see here it's looking for the starting position. We'll start at 0, 0, with an initial launch velocity of 100 meters per second, an angle of 45 degrees, and 50 data points. And we'll go ahead and plot that. Okay, and you can see here the output showing the max height, the rise, the range, the distance traveled, as well as its location when it reaches its maximum height. So let's see here, we'll go ahead and run that again. We'll change some of the inputs. So this time we'll start at 50 meters in and 50 meters up. And we'll go ahead and launch that. And so here you can see that the yellow dot is its starting position, which has moved up and over, and we can see that the output data has changed with respect now to the change in starting position. So we can go ahead and change some angles on there. Go ahead and run that at a 70-degree angle. And you can clearly see that it is a steeper angle there. And also, as part of this project, we are to have a loop. So here is the projectile loop. This is showing a projectile launch at 100 meters per second. The initial launch is at 10 degrees and increases in 10-degree increments. So here we have 10, 20. This is now our 30-degree launch. And one note on this function, this is ideal conditions. There is no wind, no air resistance. This is a perfectly ideal scenario. So here is the 50-degree launch landing right where the 40-degree launch landed, 60 degrees, and so forth. And move that over. And you got here our outputs as they are falling back down. You can see what is going on there. So here we have that 80-degree launch, and the final launch is going to be at 90 degrees, and we would expect that to be straight vertically up, which we can clearly see it is right along the y-axis, and then falling back down, and our output data showing that the all motion was in the y direction. There was no motion in the no change in distance along the x-axis. And so that is going to conclude the this function.